And we could say that God put that same sort of variability into dogs and into cats and into elephants and so on. That's why look around the world, billions of people, we're all basically a little different, aren't we? Think about it, and each one of you has a unique combination of information. You know, some of you have information for black hair, some for brown hair, some don't look like you got information for hair. Actually, you do, it's just you're sort of more like poodles, if you know what I mean. But anyway, we'll talk about that later on. But you see, imagine we've got this male dog and female dog, and we know that in the male, the sperm is produced, the gametes produced with half the number of chromosomes. In the female, you get the egg produced and so on. And so you can imagine from the male, we could get big A, big B, big C, and from the female, big A, big B, big C. So you get an individual, fertilization. 2 big A's, 2 big B's, 2 big C's. And then you could get some other individuals, 2 little A's, 2 little B's, 2 little C's. In other words, you could get different combinations from the parents, and there are millions and millions of possible combinations. They're all going to be dogs, they're all going to be a little different, but they're all still 100% what? Dog. Exactly. So we get, well, this variation within the dog kind. Say, okay, it's sort of like looking around this room here, we see we're all humans, all a little different, but we're still 100% what? Human. Okay, now, you say, all right, I can understand that, but how do we get such different varieties as wolves and dingoes, coyotes, and so on? Well, let me explain it this way. Let's use our biblical glasses. We're going to put in our biblical glasses, okay, like we talked about in other lectures. We're going to look at the world through our biblical glasses, and we're going to go into the Bible and look at biblical history. We're going to consider the event of Noah's Ark. God sent 2 of every kind of land animal, 7 of some, on board Noah's Ark. Noah's Ark landed in the Middle East. So Noah's Ark must have had 2 dogs. It had 2 of all the unclean kind. So 2 dogs are on Noah's Ark. So 2 dogs get off Noah's Ark, and they get married and have kids, and their kids get married and have kids, and their kids have kids, and they end up with lots of dogs again. Okay, but this time, we've got a world that's basically empty, and all sorts of different environments, because now things have run down, the flood has destroyed the earth and so on, so there's all sorts of different environments. And we know in biology that there are some things that can happen that can cause what we would call rapid speciation. If you take a large population and you just take a small population from that large population and take it off on its own and isolate it, maybe even just a pregnant female to start a new population, then they're called a founder population. Now, understanding the founder principle and things like genetic drift and jumping genes, you don't have to worry about all that. Things that happen in genetics, what can happen is that genes can be easily lost from a population. Genes that normally don't show up so much in a population can be exhibited in a population very quickly. In other words, you could actually get quite rapid speciation. In fact, think about this. Think about dogs getting off Noah's Ark and a small population breaking off and moving in one direction, and another small population breaking off and moving in a different direction. And as a small population moves towards, say, a cold climate, those that happen to have the genes for long hair to survive a cold climate survive better than those that have genes for short hair, and so eventually you only get long-haired dogs. And the opposite in a hot climate. In other words, if we have L representing long-haired genes, S representing short-haired genes, imagine that medium-furred dogs get off Noah's Ark, all right? And only those with the L genes eventually survive in a cold climate. All those with the S genes die out. You'll produce